Bismillahirrahmanirrahim. Another tutorial on parallel circuits. In this video I will discuss how to solve parallel circuit. It means you need to find out voltage and currents of the resistors or any other elements present in parallel circuits. I am restricted to resistive circuits only. There are two methods of solving parallel circuits. First method is with the help of Ohm's law. I discussed this method in part 1. In this video, I will discuss the second method, and this is current divider method, and its formula is written here. So let's solve the first example. Here the same circuit which I discussed in part 1. This is RT, that is the equivalent resistance of R1 and R2. This is the equivalent resistance of these two resistors, and the total current is I1, which is equal to 200 milliampere. So this is the formula for current divider method. IN is equal to RT divided by RN multiplied by IT. IN is any resistor connected in parallel. For example, if I consider R1, so IR1 is calculated with the help of this formula, and the resistor value will be 1 kilo ohm, which I substitute here. And IT is the total current, that is here. This is the total current IT, and RT, that is the equivalent resistance of both R1 and R2, and it is 500 ohm. So let's solve. IR1 is equal to 500 divided by 1000 multiplied by 200. IR1 is the current flowing through R1, and we substitute values accordingly. R1, that is substituted 1000 ohm, is substituted here. 500 ohm, that is equivalent resistance, and IT, this is IT. Answer is IR1 is equal to 100 milliampere. The total current source is in milliampere, so the answer is also in milliamperes. Similarly, R2 is the same value. R2 has the same value as R1, so IR2 is also 100 milliampere. No need to calculate because both resistors have same values. There is another circuit, again the same two resistors but with different values of R1 and R2. So let's start calculating the value of current flowing through R1, that is IR1. IR1 is equal to 91, that is the total resistance or equivalent resistance divided by 1000 ohm or 1 kilo ohm, that is R1, multiplied by 200, which is total current IT, and it is calculated as 18.2 milliampere. Very simple. The same formula for R2, change it to 2, and it is 100 ohm, and it is multiplied by 200, and its value is 180 milliampere. Very simple. I hope you understand. This is another circuit with 3 resistors and a current source of 10 milliampere. We need to evaluate the current flowing through R1, the current flowing through R2, and flowing through R3. We need to evaluate the current flowing through R1, that is equal to IR1, Substitute values. RT is 62.5 ohm, Rn is 700, that is R1. Rn is here is 700 and IT is 10 milliampere. Substitute values and we get 0.89 milliamperes flowing through R1. Now calculate current flowing through R2. The current flowing R2 is IR2, and after calculation we get 3.12 milliampere. In the same way, IR3 is equal to 6.2 milliampere. Substitute values as we did previously. This is last example. In this example, there is a voltage source V1 of value 5 volts and 3 resistors R1, R2 and R3, and their equivalent resistance value is RT, which is equal to 62.5 ohm. To solve this example with the help of current divider method, we need to find out the value of IT, that is the total current flowing because of this voltage source. So with the help of Ohm's law, we will find out IT and the current flowing through each resistors will be find out with the help of this current divider method. V is equal to IT RT, and IT is equal to 5 divided by 62.5, and it is calculated as 80 milliampere. So we get the value of IT as well, and now we are going to calculate current flowing through R1 and R2 and R3 with the help of current divider method. So let's get started. IR1 is equal to RT, which is equal to 62.5, and Rn, here Rn is R1, which is equal to 700 and 80 milliampere. The current flowing through R1 is equal to 7 milliampere. Calculate IR2. IR2 is equal to 25 milliampere. Just remove values. That is 700 with 200, and 1 is replaced with 2, that is current flowing through R2. Similarly, calculate R3 just by replacing values only. This is IR3, and here 100 ohm, and it is calculated as 50 milliampere. Very simple. I hope you understand. Thanks for watching. Goodbye for now.